A network address identifies an entire IP network, not a specific host. This is achieved by setting the host portion of the IP address to all zeros. For instance, in a Class A network, the first 8 bits define the network, and the remaining 24 bits are 0. A direct broadcast address is formed by setting all bits in the host portion of the IP address to 1. It targets all hosts on a specific IP network. This address is not assigned to any single host, but is used to send a packet to every device on the subnet. Every device in the subnet receives and processes a packet sent to the direct broadcast address. A limited broadcast address is used when a host needs to send a packet to all other hosts on the same local network. It is represented by the address 255.255.255.255, which means all bits in both the net ID and host ID fields are set to 1. Unlike a direct broadcast, this address does not target a specific network. It simply reaches everyone on the local network segment. A key characteristic is that routers do not forward limited broadcast packets. The transmission is strictly confined to the local broadcast domain. The address 0.0.0.0 is a special source address used by a host that does not yet know its own IP configuration. It represents this host on the local network and is typically used during the bootstrapping process, such as when requesting an IP address via DHCP. When a host sends a message with this type of source IP address, it signals that it is not yet assigned a valid IP address. The IP address, where the net ID is all zeros and the host ID is a specific value, is used to refer to a specific host within the local network. The address is valid only within the local network and cannot be routed beyond it. It can be used by either a host or a router, but only in a local context. IP addresses in the 127.0.0.0/8 range are reserved for loopback communication, which enables a host to send packets to itself. These addresses are used by applications for internal testing and inter-process communication, allowing software components to exchange data without leaving the host machine. Any packet sent to a loopback address is processed locally by the IP stack and never forwarded to the network interface. This means that loopback traffic is completely isolated from the physical network. The loopback mechanism is essential for software development, debugging, and scenarios where services must be tested without relying on external connectivity. This example illustrates how classless interdomain routing enables the allocation of a precisely sized block of IP addresses. Here, we have a /29 network, which means the first 29 bits represent the network prefix, leaving 3 bits for host addresses, yielding a total of 8 IP addresses. Classless interdomain routing flexibility allows efficient use of address space, especially important in subnetting scenarios where address waste must be minimized. The Internet Assigned Numbers Authority is the central body responsible for the global coordination of IP address assignment, covering both IPv4 and IPv6. Internet Assigned Numbers Authority is part of Internet Corporation for Assigned Names and Numbers, a non-profit organization that oversees global Internet resources and was established in 1998. Internet Assigned Numbers Authority not only allocates IP address space, but also manages the root DNS system and other Internet protocol resources. Rather than assigning IP addresses directly to end users, it delegates large blocks to 5 regional Internet registries. These registries, in turn, allocate address space to local Internet registries, typically ISPs or large institutions, who then assign network prefixes to their customers. The global pool of IPv4 addresses is officially exhausted. In 2011, Internet Assigned Numbers Authority allocated the last remaining blocks to the regional Internet registries, and since then, most of them have depleted their available IPv4 space. IPv4 uses only 32 bits, allowing for approximately 4.3 billion unique addresses. While that seemed sufficient in the early Internet era, the massive growth of connected devices quickly revealed the limitation of this design. The only long-term solution is migration to IPv6, which uses 128-bit addresses, enabling an address space of 2 to the power of 128 addresses, vastly larger and future-proof. The map and graph on the slide illustrate the depletion timeline by region, showing how the need for scalable addressing is now critical for sustaining Internet growth.